Because you guys have never seen a graph like this before, I do want to take a quick minute to explain what exactly is an asymptote. And if you do graph functions like this, you'll see they end up looking, they have these kind of crazy shapes that look something like this, and there'll be maybe a big break in it somewhere, and then it'll kind of shoot off like this, or maybe we'll see some later on that look, maybe it goes up like this and shoots off like this, and then it'll do like this in the middle, and then something like that. And so it's this leveling off behavior and these lines they can't cross that we're talking about in this section. These are called asymptotes. And this is not a good drawing over here. I should have had this whole thing moved up. Let me push this up a little bit. There'll be a leveling off behavior often, and then some kind of line they can't cross. And those dotted lines I'm drawing are called asymptotes, and they're these guidelines that come about based off different things that are happening with the functions. And you can look in the notes to see what they say, but I'll explain it verbally as I do it. The easiest one to understand probably is the vertical asymptote. That's the one that goes, vertically. And it's going to go through some line of x equals 2 or x equals -1. And it's all about making sure we don't ever divide by 0. So the VA is looking at, that's what I'm going to call a vertical asymptote. The VA is all about making sure we're not dividing by 0, because we know that we can't divide by 0. So if I look to see what makes that denominator equal 0, that's an x value that I cannot use. Therefore, my graph is not allowed to touch it. And I'm going to put a big, fat, basically like a fence there, called an asymptote, that says, don't go here. So they gave us a decimal value for the vertical asymptote in this case. So that's going to be about 3.5. So I would graph at about at 3.5. I would put a big vertical line. And when I do finally graph this function, it would not be allowed to touch this line. So as it approached this line, it would either veer way up or it would veer way down. But more about that in the next section. Right now we're just doing the boundary lines. As far as the horizontal asymptote goes, this is a little bit more nuanced. You have to kind of use your brain a little bit more. It's a concept for sure. But here's the general idea. The horizontal asymptote is going to give us some kind of, if there is a leveling off behavior, it'll follow the horizontal asymptote. And leveling off behavior looks something like this. As I get really big values of x, it's going to kind of just level off. So what we're talking about really is how these two functions compare. Now, if you just look at the rules themselves, the way I wrote them, we're going to look at this guy's degree and this guy's degree. Now, degree, if you remember back from chapter whatever it was, it has to do with the power, the exponent on the highest powered terms. This guy would be considered degree 1. This guy is also considered degree 1. These guys have a matching degree. So the short answer is, since the degrees match, the horizontal asymptote is going to be at y equals, I wrote in the notes, ratio of lead coefficients. That means this number divided by this number. So that's going to basically be, end up being -4. So I would have a horizontal asymptote at -4. If you want to make a little bit more sense of these rules, I just want to explain one thing. If you're satisfied with what I've said so far, you can stop the video here. But if you want to understand why these rules are what they are, here's the idea. The leveling off behavior is kind of meant to speak to what happens for very, very, very large values of x and very, very negative values of x, extreme values of x. And what I want to point out to you guys is if I take a really big value for x, these other little piddly terms, they don't really matter, right? If I had, if x is 1,000 and I take -8,000 and I add 11, it's not that big of a deal. So another way to think about horizontal asymptotes is to kind of look at the most powerful term for each part of the thing and ignore every other part of this and look to see what kind of expression you get. I would get something like this. And if this thing simplifies completely, well, these x's totally cancel off and I'm left with just -4. That means that for really large x's, these don't really matter so much, and this is basically going to always be -4 because all the x's went away, and that's going to be another way to think about the horizontal asymptote in this case. In the cases where the denominator has a bigger power or the numerator has a bigger power, you have to think about it slightly differently because all the x's aren't going to cancel away. But this is why that rule exists. This is why when the powers tie, we can just look at the ratio of those coefficients, make it a y equals, because that's how we make a horizontal line, and graph that. And now we know our graph, as x gets really large, will definitely level off here and level off there. Good luck with these, and be patient with yourself.